Human activity is pushing our planet to its absolute limits. With resources depleting and ecosystems rapidly dying out, we are approaching a strict expiration date for our homeworld. Global temperatures continue to climb, triggering the structural collapse of massive ancient ice shelves. If these extreme environmental shifts continue at their current pace, climate scientists project that Earth could become largely unlivable within the next 100 years. To guarantee the survival of our species, we have to look beyond our own atmosphere. We need to abandon the only home we've ever known and find a new one. The most viable candidate for relocation is Proxima B, located in the Alpha Centauri system, 4.24 light-years away. Astronomers determined this is a rocky, Earth-sized planet orbiting in its star's habitable zone, meaning liquid water can exist on its surface. Finding the planet is the easy part. Getting there is a massive physics problem. Look at the Voyager probes, our furthest human-made objects in deep space. This diagram illustrates the math. Even if we built a spacecraft traveling 60 times faster than Voyager, moving at a blistering 1,000 kilometers per second, it would still take 1,300 years to reach Proxima B. Conventional rockets are inadequate for this timeline. Success requires a self-sustaining ecosystem, a floating mini-planet capable of supporting thousands of lives for centuries. This is the Chrysalis, a proposed generation ship spanning 58 kilometers in length, dwarfing several known moons and asteroids in our solar system. Weighing an estimated 2.4 billion tons, a structure of this magnitude cannot launch from Earth's surface. It has to be assembled entirely in space over 25 years, utilizing resources mined from the Earth and Moon, with thousands of 3D printed components. This map highlights exactly where construction would happen. Lagrange Point 1. It is a gravitationally stable zone positioned directly between the Earth and the Sun, sitting roughly 1.5 million kilometers from our atmosphere. At 58 kilometers long, the Chrysalis represents the most ambitious engineering project in history, far exceeding the scale of any previous human structure. To function over millennia, the Chrysalis is split into 3 main segments. 2 colossal fuel modules make up 90% of the entire ship's mass, trailing behind a single 3-kilometer-long habitat module. This schematic breaks down the interior of that habitat module. It is divided into 5 distinct zones: agricultural fields for food production, communal park spaces, multi-generational housing, industrial and medical labs, and a central structural core that generates continuous artificial gravity. The ship will carry an initial crew of 2,400 people. Before they board, these individuals must undergo 70 to 80 years of intense, specialized isolation training to adapt their minds and bodies to a permanently closed environment. To accurately simulate these extreme psychological conditions, scientists plan to run this training out here, isolated in the freezing, barren environment of Antarctica. Moving a 2.4 billion-ton ship out of our solar system requires massive energy. The design relies on a direct fusion drive, propelled by a steady mixture of helium-3 and deuterium fuel. The engine's core principles rely on the same nuclear fusion research currently operating in experimental facilities on Earth. This graph tracks the ship's projected speed. The fusion drive allows for constant acceleration, gaining 40 kilometers per second every single day until it hits a cruising speed of 3,000 kilometers per second. Even traveling at that blistering speed, the journey to Alpha Centauri takes up to 5,000 years. An onboard artificial intelligence will monitor and manage the population across the centuries, strictly capping the colony at 10,500 people to prevent resource depletion. The crew that waves goodbye to Earth will never see the new world. Hundreds of generations will live, work inside the ship, and ultimately die, knowing only its metallic walls. Millennia later, the dark void of deep space will give way, and the destination will finally come into view. This triggers the most dangerous phase of the entire mission. To safely approach the planet, the ship must jettison its 2 massive depleted fuel modules. This graphic shows the deceleration process. The main engine fires in reverse for a full year. By shutting 1 meter per second every second, or 0.1 g, the ship safely bleeds off thousands of years of momentum. With the excess weight gone, the 4 million-ton habitat module will insert itself into the orbit of Proxima B. A final generation of humans, people who have never breathed uncycled air or touched real dirt, will board small transport shuttles, descend to the surface, and establish the very first temporary shelters. While currently a hypothetical blueprint, the Chrysalis represents the definitive roadmap for humanity to leave Earth behind and establish ourselves as a permanent interstellar civilization.